Hello everyone. So the alkali metals chemical properties will continue today. We continue with the alkali metals chemical properties. Already some of the properties we have discussed. Okay, ma. Now check it here. Suppose yesterday we stopped discussion at this point. It is the reaction of lithium with what? Ethyl alcohol. Reaction of lithium with ethyl alcohol. So this ethyl alcohol is nothing but C2H5OH, means some alcohol it is. C2H5O minus will be there and H plus will be there. So the C2H5O minus ion is called ethoxide ion. Ethoxide. So in this case now, in this molecule, a C2H5O minus Li plus. So lithium ethoxide is the compound produced here along with the release of what? Hydrogen gas. So this was yesterday discussed, right now. So it is one important. Suppose if you take methyl alcohol in CH3OH, it is called methyl alcohol. Methyl alcohol is also called methanol. And this one is what now? Ethyl alcohol is also called ethanol. So ethanol, ethyl alcohol, both same. Ethanol is IUPAC name. Okay, and the common name is ethyl alcohol. Here methanol is IUPAC name. Methyl alcohol is common name. So in this case also, a CH3O minus is called methoxide. What is ion called? Methoxide. So methoxide ion is what? CH3O minus and H plus hydrogen ion. Like this, by losing H plus ion, it will convert into CH3O minus. Here also, the C2H5OH molecule, C2H5OH ethyl alcohol molecule loses on H plus to form ethoxide ion. So here, ethyl alcohol is producing what? H plus now? Ethyl alcohol is producing what? H plus ion. So if any substance produces H plus ion, that is called what? Acid. Remember, ethyl alcohol is able to produce H plus now here. If any substance is ready to produce H plus ion, that must be taken as acid. So here ethyl alcohol is acting as what now? Acid. It acts as what? Acid. That point keep in mind. Why? It is producing what? It produces H plus ion. So after producing H plus ion, it is converted into which anion? C2H5O minus, which is called ethoxide ion. So sodium ethoxide. Is that clear, ma? So it's about what now? The reaction of alkali metals with alcohol. Reaction of alkali metals with alcohol. Now tell me the reaction of sodium with ethyl alcohol. Sodium with ethyl alcohol for what? The same thing. Ethyl alcohol we write like this. Sodium Na plus CH3 bond CH2 bond OH. This one also ethyl alcohol only. CH3, CH2OH also ethyl alcohol. So the same thing, C2H5OH, I have expanded like this. Now in this case, H plus is hydrogen ion. H plus is hydrogen ion. The remaining part, CH3 bond, CH2 bond, O minus, is called what? Ethoxide ion. Ethoxide ion. So when sodium reacts with this ethyl alcohol, what happens? Tell me. It is what now? Ethyl alcohol. Ethyl alcohol. So when sodium reacts with ethyl alcohol, what will be the compound produced here? CH3 bond CH2 bond ONA. OH becomes what now? ONA. Here Na plus. In place of H plus, what is substituted here? Na plus is present here. So here O minus, this one CH3 CH2O minus is ethoxide, and it is sodium ethoxide now. What is produced here? Sodium ethoxide is produced. Along with this, which gas is released? Hydrogen gas is released. So hydrogen gas is released when sodium reacts with what? Ethyl alcohol. Is that clear now? So this is the test for what now? Alcohol. Whether the given solution, whether the given liquid is alcohol or not. If you want to find out, we use what? Alkali metals. Alkali metals will produce what? Will liberate what? Will release, evolve hydrogen gas here. That point keep in mind. Next, another one is what? Affinity. Affinity for non-metals. Affinity for non-metals. So affinity means what? Here, love. Affinity means what? Here, love. Electron affinity meaning what? The affinity towards electron. Here affinity towards what? Non-metals. Now here alkali metals are what? Affinity of what? Affinity of alkali metals. Affinity of alkali metals towards what, ma'am? For non-metals. That means what? The metals will have affinity for non-metals. Metals will combine with non-metals. Okay. So now see, alkali metals have great affinity. They have great attraction for non-metals. Okay, ma'am. So generally non-metals will be present in what? P block. In P block, non-metals will be there. And alkali metals belong to what? S block. Is that clear? Now, the reactivity towards hydrogen. The reactivity of what? Reactivity of alkali metals towards what? Hydrogen. Okay. Now, the alkali metals combine. The alkali metals combine directly with the hydrogen. Need not to heat. Need not to heat. Directly they combine with hydrogen to form what? Crystalline hydrides. Crystalline means crystal solids. In the form of crystal solid, the hydrates of alkali metals are produced. We have the formula MH. Here M plus cation and H minus anion. Generally, hydrogen will be forming what? Cation. Generally, H plus is called hydrogen ion, we say. What we say? Hydrogen ion. It is cation of hydrogen. Now, H minus is called what? Hydride ion. H minus is called hydride ion. So, this H minus, the hydrogen gets -1 oxidation state only with strong metals, only with more metallic elements, only with more metallic elements, the hydrogen will be giving what? -1. Okay. Suppose you take NH3. In NH3, each hydrogen has what? +1. +1 into 3, +3. Each nitrogen has what? -3 here. So nitrogen is what now? Non-metal. With non-metals, the hydrogen will be exhibiting how much oxidation state? With non-metals, hydrogen shows what? +1 oxidation state. Whereas the hydrogen shows -1 oxidation state only with the alkali metals and alkaline earth metals. Like what now? NaH, here Na plus only. Always Na will have +1. Hydrogen will have -1 here. And MgH2, MgH2 magnesium hydride. In this, magnesium must be having +2. Then hydrogen each one -1. So each hydrogen is what? -1. Is that clear, ma? So each hydrogen is -1 here. So like this now here, the hydride ion is nothing but H -1. Okay. So like this is the point. And hydride ion, each hydride ion has how many electrons, ma? 2 electrons. 1 electron of hydrogen atom and -1 indicates 1 electron is gained from outside. So it got which configuration? Helium configuration. Electronic configuration of what? Helium. So electronic configuration of helium is attained by H minus. So H minus is more stable ion having 2 electrons. And what is this here? H plus? H plus ion has 0 electrons. No electrons. 0 electrons. No electrons in H plus. Already hydrogen atom lost 1 electron. That 1 electron of hydrogen atom has been lost. So no electrons here. But in this, what will be there? 1 proton will be there. 1 proton. 1 proton is present. Anyhow, hydrogen does not contain neutron. Neutron is not present. And H plus has lost. H plus is formed after loss of what? Electron. So no electrons in the H plus. But 1 proton is there in H plus. So H plus should be taken as what? Proton. H plus is nothing but proton. Otherwise, we say hydrogen nucleus. Hydrogen nucleus is nothing but proton. In the nucleus of hydrogen, there is no neutron. So the nucleus of hydrogen or proton is indicated by what? H plus. Okay. So it is about what now? Hydrogen ion and hydride ion. So in this metal hydrides, what will be there? The H minus will be there. Now what is this NH3 called? Hydride of what? Non-metal. Hydride of non-metal. Non-metal is what? Nitrogen here. Hydride of non-metal. But here it is what? Magnesium hydride is what? Hydride of metal. In hydrides of metals, the hydrogen shows -1 oxidation state. That point keep in mind. And these hydrides are ionic. These hydrides are what? Ionic compounds. So this magnesium hydride is what? Ionic compound. Ionic compound. And sodium hydride, NaH. NaH is what? Ionic compound. But this hydride of ammonia, hydride of nitrogen is what now? Covalent. Covalent compound. So covalent compound is what here? The hydride of non-metal. But the hydride of metal is what? Ionic compound. And contains the hydride ion, H minus ion. And contains what? These hydrides contain what? Hydride ion. So here metal atom, alkali metal atom with zero charge initially. Initially, all metal atoms will be having zero charge. So two atoms of alkali metal interacting with hydrogen directly. No further heating required here. No heating is required. Directly they react to form MH. Here M plus 1, H minus 1. So it is a reaction of alkali metals towards what? Towards hydrogen. Okay. So wherever you require the screenshot, you can take. Wherever you feel that you have got extra point, please take the screenshot and then we go to next page. Okay. Now next one's here. The electrolysis of the fused hydride. Electrolysis of fused hydride. So fused meaning what here? Molten. Molten. Okay. Suppose if you take LiH solid, on heating this LiH solid, it will become molten LiH. This is now fused or molten, LiH will come. Now in this here, in LiH, what are there? Li plus 1 cation, H minus 1 anion. Now what will be the ions available here? Cation is what? Li plus, and anion is what? Anion is H minus. Now what is the anion available here? H minus. What is cation available? Li plus. Now what is the difference between fused lithium hydride and solid lithium hydride? Between solid lithium hydride and fused lithium hydride, what is the difference? Difference is that here cation anion in solid Li plus, in solid LiH, the lithium cation hydride anion will be held together. They are closely packed. They are not moving. But in molten or fused LiH, the Li plus is mobile, H minus is mobile, means movable. They are moving. That's why they will carry electric current. They will conduct electricity. The fused or molten LiH is good conductor of electricity. But this one solid LiH is what? Bad conductor of electricity because ions are there, but they are not moving. Ions are not moving here in solid state. In molten state, they are moving. Okay. And now here, electrolysis meaning what? Passing electricity. Electrolysis means meaning what? Passing electricity. Okay, passing electricity through any substance, through any solution is called what now? Electricity, electrolysis or electrolysis. Now tell me here, to pass electricity, what we need? We need one vessel, electrolytic vessel. Here cathode, anode. So cathode, anode. So cathode will be having what now? Cathode attracts what? Cations. Generally cations will be having which charge? Li plus. Now anions will be having what? Negative charge. Anions have negative charge, cations have positive charge. Now cations are attracted by cathode. Cathode attracts what? Cations. Anode attracts what? Anions. Now these positive ions to be attracted, to attract the positive cations, this cathode should be having what? Negative charge. Remember, the cathode must be having negative charge so that it will attract what? Cations. And the anode must be having positive charge. Anode must be having positive charge so that it will attract what? Minus ions, negative ions. So anions are attracted by anode, cations will be attracted by cathode. Now here at anode, what happens? These H plus ions will lose electron. Each H plus loses one electron. Each H plus loses one electron to form H atom. Now two H atoms combine to form what? H2 gas. H2 gas. So H2 gas is produced at anode or cathode here? At anode. At anode, we got what? H2 gas. The hydrogen gas is produced at anode during electrolysis of lithium hydride. See now here what they said. The electrolysis of the fused or molten hydride, lithium hydride, yields. Yields means produces. Yields meaning what? Produces hydrogen gas at anode. Hydrogen gas at what? Anode. So hydrogen gas at what? Anode. Anode is produced. So other hydrates decompose before melting. Other hydrates will decompose before the melting only. When you are trying to melt the other hydrates, they will be decomposing into lithium and hydrogen before melting only. But lithium hydride will be melting easily. Okay, next. The hydrates react with water. The hydrates react with water, liberating hydrogen gas. Now, see here, metal hydride, NaH, imagine here. What do you imagine? NaH, metal hydride, Na plus, H minus. M plus cation of alkali metal and H minus hydride ion. In H2O, what will be there? No? H plus and OH minus, we know. In water molecule, what will be ions available here? H plus cations and OH minus anions, right? Now M plus will take what? M plus will take which ions here? OH minus. M plus cation will take what? OH minus anion. Then what is formed here? MOH is formed. M plus 1, OH minus 1. Is that clear, ma? Next one here, the H plus ions will be released. Here H plus, H minus. In this case, H minus is there. Here H plus is there. The H plus and H minus will combine to form what? H2 gas. The H2 gas is produced. Is the concept clear? So the metal hydrates of alkali metals dissolve in water, react with water to form what? MOH and H2. MOH means what in this example? NaOH you can take. NaOH and H2. Next. The ionic character of the bonds in these hydrates means what? MH. MH hydrates increases. The ionic character increases from where to where? From lithium hydride to cesium hydride. So cesium hydride is more ionic. Cesium hydride is more ionic in nature, and lithium hydride is what? Less ionic. And their stability decreases in the same order. Stability will be decreasing. Now cesium hydride is more ionic but less stable. Less stable. Is that clear, ma? So cesium hydride is what? More ionic, but less stable. Stability will decrease from lithium to cesium hydride, whereas ionic nature will increase from lithium hydride to cesium hydride. Okay. Now, next, they are powerful reducing agents. They means what here? Metal hydrates, the alkali metal hydrates. Alkali metal hydrates are powerful reducing agents. Powerful reducing agents means they easily undergo what? They easily undergo what? Oxidation. So powerful reducing agents meaning what? Easily they undergo oxidation. If any substance undergoes oxidation easily, it will act as what? Powerful reducing agent. So MH compounds, MH means what here? Alkali metal hydrides are powerful reducing agents because what here? They are undergoing oxidation easily. Especially at what temperatures? High temperatures. At high temperatures, they will act as what? Powerful reducing agents. Is that clear, ma? Next one here. Now here, silicon tetrachloride. Silicon tetrachloride. In this, silicon has +4 because each chlorine will have -1, na? -1 into 4, -4. So each chlorine has -1. -1 into 4, -4. Therefore, silicon should be having +4 here. Oxidation state of silicon, how much here? +4. It is interacting with the sodium hydride. Sodium hydride, metal hydride of alkali metals. Na plus is there here, H minus is there. Is that clear, ma? Now these two, when they react with each other, we are getting what? Silicon hydride. Silicon hydride. In this case, now here, the silicon and hydrogen. And here NaCl, sodium chloride. So Na plus will combine with Cl minus to form NaCl. Then Si plus 4 will combine with H minus to form this one. Now here each hydrogen has what? Now -1. Each silicon has what? +4. Each silicon has +4. Now, if you take hydride, any change in the hydride now? Here, Cl minus, Na plus, Na plus, Na plus, Na plus. Is that clear? Next one, what now? Silicon tetrachloride is interacting with sodium hydride to form what? Silicon tetrahydride. Okay, silane we say here. Silane. What we say? Silane. Like what now? CH4 is called methane. Na? CH4 is called methane. CH4 is called methane. The same way, SiH4 is called silane because carbon, silicon, germanium, tin, lead. These are what now 14th group elements now. Now CH4, if it is giving, SiH4 will be forming. CH4 and SiH4. So this is silane here. Silane is produced here along with NaCl. Okay. Next, reactivity towards oxygen. Okay, the reaction of alkali metals with oxygen. So oxides and hydroxides. Oxides and hydroxides. So okay, so with oxygen in the form of what oxides and hydroxide, they will be reacting. So affinity towards oxygen increases. Okay, so that means lithium to cesium if we take, which will be reacting more faster with oxygen, cesium will be reacting. So affinity of these metals, alkali metals, will increase with oxygen. When heated in atmosphere, what is there? Oxygen is there, no? When heated in atmosphere or air, okay, of oxygen, what happens now? The alkali metals ignite, they will burn and form oxides. They will ignite, they will burn and form what? Oxides. Alkali metal oxides will be produced. On combustion, lithium forms what? Li2O. On combustion is burning only. Burning any substance in air is called what? Combustion. Burning any substance in air is called combustion. So on combustion of lithium in air, it will produce what? Lithium oxide. Next, sodium will give peroxide, sodium peroxide, Na2O2. Here O2 minus 2, O2 minus 2 ion is called what? Peroxide. O2 minus 2 is called peroxide. Na plus 1, how many there? 2 there. Na plus 2 ions are there. And potassium, rubidium, cesium, these will give superoxides. Superoxide formula what? O2 minus 2. O2 minus 1. O2 minus 1. So O2 minus 1 is called what? Ma? Superoxide. O2 minus 1 is called superoxide. So M plus 1 here, we know that M plus 1. Alkali metal will be having plus 1. M plus 1 and O2 should have minus 1 here. So for 2 atoms of oxygen, minus 1. Then for each oxygen, how much? Minus 1 by 2. For each oxygen, how much here? Minus 1 by 2. So O2 minus 1 meaning what? Oxygen with minus 1 by 2 oxidation state. Oxygen with minus 1 by 2 oxidation state in superoxides. Here in this case now, when O2 minus 2 is there, when O2 minus 2 is called peroxide, each oxygen is getting what? Minus 1. 2 oxygens got minus 2 here. Then 1 oxygen gets minus 1 here. So this is what now here it is called peroxide, and O minus 1 by 2 is called superoxide. Now here the metal atom first undergoes combustion in air. Combustion in air, burning in air will give oxide. So here O minus 2 here. O minus 2 is called oxide. O minus 2 is called oxide. Here each metal will be having plus 1. Plus 1 into 2 plus 2. Further, this metal oxide, normal oxide, mono oxide will undergo oxidation in air. Again, combustion will continue to form what? M2O2. Here O2 minus 2. O2 minus 2. And each metal has plus 1. Plus 1 into 2 plus 2. It is peroxide now. Again, the same peroxide will further undergo oxidation to form superoxide. Superoxide. So O2 minus 1 here. O2 minus 1. So 2 atoms of oxygen will get minus 1. Each oxygen gets minus 1 by 2. So this is called superoxide. Potassium superoxide, rubidium superoxide, cesium superoxide. So like this we get potassium, rubidium, cesium will form superoxides. Sodium will form mostly peroxide. And lithium forms what? Only oxide, monoxide. Lithium cannot form peroxide and superoxide. That point given. Why here? Why these potassium, rubidium, cesium are able to form superoxides? The sizes, if we take the sizes order, if we take O2 minus has more size than O2 minus 2, more size than O minus 2. Here oxide, here it is superoxide. Superoxide. Now, whose size is greater? Superoxide. Here whose size is smaller? Oxide. So here and K plus, which one size? Whose size is greater? Cesium plus is greater or lithium plus is greater? Whose size is greater? The cesium plus will be larger sized. and lithium plus will be smaller sized. Now, the large cation can stabilize large anion. The large anion is what? Superoxide. Na? Superoxide is what? Large anion. And what is large cation? Cesium plus. So the large cation can stabilize large anion. So cesium will be forming only cesium superoxide easily. And small cation, this is lithium plus one small cation. Small cation can stabilize small anion. Here, a smaller anion is what? Oxide. The smaller anion will be stabilized by smaller cation. So this way we have to understand concept. Okay, ma'am. So these all are superoxides, peroxides. Okay. Next one, the normal oxides contain O minus 2 ion. Which ion here? O minus 2. And the peroxides contain O2 minus 2 ion. And superoxides contain O2 minus ion. The peroxides and superoxides become more stable with increase in atomic number of alkali metal. When atomic number is increasing, size will be increasing. Na? When atomic number increases, what happens now? The size also increases. Na? The size of alkali metal also increases. With increase in size or with increase in atomic number, what happens? The stability will be increasing. So cesium superoxide will be more stable. The formation and stability of these oxides can be explained on the basis of lattice energy effects. Lattice energy. Li plus ion being a small ion, small cation, it has what? Stronger positive field around it. Stronger positive field around it. So lithium plus, this positive plus one charge is more in small size. But if you take cesium plus large anion here, again charge plus one only. A small cation plus one charge. A large cation plus one charge. Here, where more positive charge field is there, here lithium small size cation has more positive charge field. That's what is said here. So lithium ion being a small cation has a strong positive field around it and can stabilize only a small anion. O minus 2 is small anion here. So O minus 2 small anion can be stabilized by Li plus. Whereas Na plus being a large cation, it is larger than lithium plus, na? Na plus is larger than what, ma? Na plus is larger than lithium plus. So this larger Na plus can stabilize a large ion. That is what? O2 minus 2. O2 minus 2 means peroxide. The larger anion can be stabilized by Na plus. Still cesium plus, very large cation can stabilize very large anion, that is O2 minus. Superoxide can be stabilized by cesium plus. So this way we have to take each oxygen atom has got minus 2 here. It is oxide. Read O minus 2. Don't read O2 minus. Don't read O2 minus. Read O minus 2. Charge you read first. O minus 2. Here you see in superoxide how to read? O2 minus. Here you must read O2 minus. Here O minus 2. It is oxide ion, and peroxide is what now? O2 minus 2. O2 minus 2. Two oxygens will have minus 2 charge. Now here in peroxide, what we have to understand, between oxygen and oxygen, there will be single bond. Each oxygen has got what? 2 bonds, you see. This oxygen got 2 bonds on either side. This oxygen has got 2 bonds on either side. So it is what now here? Each oxygen is 2 valency, means 2 bonds. Here between oxygen, single bond is there, na? This O bond, O linkage is called what? Peroxy linkage. This linkage is called what? Peroxy linkage. Peroxy linkage. Is that clear, ma? So peroxy linkage means O single bond O. O single bond O. Okay. So this is peroxy linkage. O single bond O. Next one is superoxide. Between oxygen here, one single bond is there, one covalent bond is there, and 3 electron bond is there. You see, 3 electron bond. 3 electron means 3 is odd number, even number. Odd number. Odd means what? 3 electron here. Odd electron bond. Odd electron bond it is. So odd electron bond means what, ma? With 3 electrons. With 1 electron if bond is formed, or if 3 electrons with 3 electrons bond is formed, that is called odd electron bond. So there will be one odd electron bond in superoxide here. Okay, so it is about what now here? Superoxides, peroxides, and oxides. The remaining part we'll discuss in the next class. Okay, bye. Good day.